In this video, we're going to work through 6 examples of just mixed derivatives, just to practice each of our derivative rules. So this first example here, we need to focus on 2 of our new rules plus the quotient rule. So we need to look at the derivative of sine function and derivative of tan function. And off to the right, you notice we've placed all the rules, so they're just there as a reference for you as we go through these examples. So the derivative here then, it's a quotient, so the quotient rule says we're going to take the derivative of the top first. So 2 comes down as we use the chain rule. Sine stays 2x. The derivative of sine is cosine of 2x times the derivative of 2x, which is 2, times the bottom, which is 1 plus 2 tan squared x. That's the first part, minus, and we're out of space, so I'm going to have to put it below, minus the derivative of the bottom. So the derivative of the bottom, derivative of 1 is 0, derivative of 2 tan squared is going to be 4 tan of x, times the derivative of tan, which is secant squared x. Multiply all that by the numerator, which is sine squared of 2x. And that whole thing has to be divided by the denominator squared. And there's some simplification you're expected to do there. In this video, I'm just going to do the derivatives, just so it doesn't get too long. So make sure you can simplify a little from there. The next example we're going to do is y equals e to the 1 over x, all to the power of 3, so this is 1 over x here. And if we take the derivative, then we need the rule for an exponential derivative. So the derivative then, we can actually do this first by simplifying and writing this as e to the 3x to the minus 1. So bring x to the top here and multiply the exponents. Now if we take the derivative, well, the derivative of anything with e stays the same, times the derivative of the exponent, so the derivative of that is minus 3x to the minus 2. So there's the derivative. Again, you can simplify a little, but we won't worry about doing that here. The next example, y equals log base 5 of x squared plus pi x. Well, we have to use the log rule for derivative, so that says the derivative of a log is 1 over the argument of the log, so that's x squared plus pi x, times the natural log of the base is 5 here, so natural log of 5, multiplied by the derivative of the argument, or the derivative of the part that you put down. So the derivative of that is 2x plus pi. And that's the derivative for that one. The next example we're going to look at has a tan and a secant in it, and it's all to the power of 3, so we need to make sure, again, we use the chain rule and the tan and secant rule. So if we take the derivative here, f prime of x, well, we start on the outside and work our way in. So the 3 comes down, everything stays the same inside, and the 3 becomes a 2. Times the derivative of the inside, well, the derivative of tan is secant squared of 3x, multiplied by the derivative of 3x, which is 3, plus the derivative of secant 3x. So secant 3x, the derivative is secant 3x times tan 3x. And I'll just move this out of the way for a second. Secant 3x tan 3x times the derivative of 3x, which is 3. So there's the derivative. Again, I'll leave it to you to simplify, but the derivative part, there it is. Our next example has an exponential function again, and this time a natural log function, which is also part of a product, and the whole thing is part of a bigger chain because it has exponent 4. So if we take the derivative, 4 comes down, everything inside stays, and the 4 changes to a 3. We multiply that by the derivative of the inside. So the derivative of 4e to the 2x is 4e to the 2x multiplied by the derivative of 2x, which is 2, plus the derivative of the second term, which is a product. So we use the product rule. We'll put that in another bracket here. So derivative of the first, keep the second, plus keep the first, derivative of the second. So the derivative of ln x is 1 over x. And that's the full derivative for that one. Again, simplification left up to you. Final example for this video then has two inverse trig functions, tan inverse and cosine inverse. Notice this one is also a product here, so we have to use product rule again. So the derivative of the first, and let's put this in brackets here, 6x plus 0, keep the second, plus keep the first, times the derivative of the second. So the derivative of tan inverse is 1 over 1 plus x squared. So there's the derivative of the first part, plus the derivative of cosine inverse of root x. Well, derivative of cosine inverse is going to be negative 1 over root 1 minus root x squared, or just x if you rather, multiplied by the derivative of root x, which is going to be a half x to the minus 1 over 2. Lots of little simplifications you can do there. Again, I'll leave that to you. Here we're just interested in making sure you can apply the derivative rules. So there's a mixed bunch of practice using lots of the rules you've seen. The two next videos in this series will have 6 more examples each, so lots of practice there for you to see. Hopefully it'll help you be successful.